Hello and welcome to Vaslav's Maths tutorial. I'm going to do a past exam question from the calculator paper in June 2012, question 26, which is a vector question. Before I proceed with the question, I would like to go through a quick revision on triangular law of vectors, which states that I've already written it here. In any triangular, the total sum of all the sides going in one direction is equal to 0. So for example, OB plus BA plus AO is equal to 0, which makes sense since the displacement is 0. You're actually finishing where you started from. Okay. Further, you can manipulate the equation to get it in the form of OB plus BA is equal to minus AO, and knowing that minus AO is equal to OA, remember in any vector you can change the sign of the vector provided you change the direction of it. It cancels out the effect. So replacing minus OA by OA, sorry, minus AO by OA, then we end up with this statement that says a second triangular law of vector, which says in any triangular the sum of the two sides going in the same direction is equal to the other side going into the opposite direction. And as you can see in this diagram, for example, in this diagram, OB and BA are going same direction clockwise around the triangle, whereas the other vector OA is going anti-clockwise around the triangle. So OB plus BA is equal to OA. Okay, I think now we can go and have a look at the question. In this question, we been given that vector OA is A and vector OB is equal to B. And then we've been asked to find AB in terms of small a and small b. Well, since we want AB, meaning from A to B, so we're going to put a direction on this side. Notice you have to do this part. They haven't done that for you. Now we want to choose this big triangle and apply the triangular law of vectors. Since OA and AB are going in the same direction, but OB is going into the opposite direction, we can apply the second law of triangular vector. So I'm just going to write that OA plus AB is equal to OB. Next, we're going to replace OA and OB with the given equivalents. So that's A plus AB equal to B, and just like algebra, AB is the subject. It's the vector that we've been asked to find in terms of A and B is equal to B, and the A, taking A from both sides, you get that. So therefore AB is equal to B minus A. So next, the part B, try to squeeze it here. It's saying that the side, the point P splits AB in a ratio 3:1. So I try to show that by putting 3 parts on an AP and 1 part. So 1 part there and 3 part here. And then we've been asked to work out OP now in terms of AB. Again, you have to put the correct arrow since you're required to work out OP. So the direction should be from O to P. So now I can consider either of the two triangles, either the small triangle at the top or the larger triangle at the bottom, any triangle which involves the side OP. I'm going to use the smaller triangle since it involves 1, and that is easier to deal with. So you looking at that triangle and putting this arrow also in that direction and applying the triangular law of vectors, I can say OP is going in the same direction as PB. So plus PB must equal to the side which is going in the opposite direction, OB. Okay, so OP, so therefore let's making OP the subject, I can say OP is equal to OB minus PB. Okay, but we know that from the diagram here that PB is equal to 1/4 of AB, as there are AB has got 4 sections and PB is only 1 section out of 4 sections, so PB is 1/4 of AB. So let's put that in here, so we can say OB, which is just B as before, minus PB, I can replace it by 1/4 of AB, its equivalence, and then I'm just going to do substitution. 1/4 of AB was already worked out, was B minus A, so multiplying through I get OP is equal to B minus 1/4 of B plus 1/4 of A, just expanding. And now just gonna bring that here. OP it's equal to B, take away 1/4 of B is 3/4 of B, and plus 1/4 of A, so that becomes OP. Okay, that's for part B. Thank you.